Okay, so picture this. You're scrolling online, booking a flight, maybe grabbing takeout, just all those little digital errands we run. Now imagine an AI that doesn't just follow instructions for each task, but actually learns from them, building up skills just like you do.
Yeah, like actually learns.
That's what we're diving into today with Agent Workflow Memory, or AWM for short.
And this is a big deal because right now, most AI agents are a bit like one-trick ponies. They can nail a specific task if you give them the exact steps, but throw in a curveball and they're lost.
Exactly. It's like trying to teach someone to cook by only giving them one recipe.
Totally.
They might master that one dish, but good luck getting them to improvise with new ingredients.
This paper, Agent Workflow Memory, argues that the key to truly smart AI is the ability to learn and remember these workflows, basically, sequences of actions that achieve a goal. It's about breaking down complex tasks into reusable building blocks.
So instead of just knowing how to book a flight from A to B, this new approach would allow the AI to learn smaller workflows like finding flight options, comparing prices, entering passenger details, all these little things we humans do without even thinking.
Precisely. And here's where it gets really interesting. The paper gives this example of an AI agent learning to find a place on a map. Pretty standard, right? But here's the kicker. It then uses that same knowledge as a stepping stone to figure out how to get the zip code for that place, even though it's never been explicitly taught that.
Okay, wait, hold on. This is where my mind is blown. It's like instead of needing separate instructions for every possible map-related task, the AI is starting to connect the dots on its own, learning how to learn in a way.
And that's exactly what makes AWM so groundbreaking. It's not just about memorizing specific steps. It's about understanding the underlying logic of a task and applying that knowledge to new situations.
So it's less like following a recipe and more like actually understanding how the ingredients work together so you can start creating your own dishes.
A perfect analogy. And this is where things get even more intriguing. The researchers tested AWM in two different ways, what they call offline and online learning.
Okay, let's unpack that. What's the difference?
Think of offline learning as giving the AI a practice run. It gets to study pre-existing examples of workflows, kind of like rehearsing a play before opening night. But with online learning, it's showtime from day one. The AI has to figure out the workflows on the fly while it's actually trying to complete the task.
You're throwing it in the deep end and seeing if it can swim. So how'd it do? Was it up to the challenge?
In a word, yes. They tested it with some pretty rigorous benchmarks. Think of them as obstacle courses for AI agents. And AWM blew the competition out of the water. It wasn't just keeping its head above water, it was actually completing tasks far more effectively than any of the other methods they tested against.
So not just finishing the obstacle course, but actually setting a new course record. That's impressive. What kind of tasks are we talking about here? Give us some examples.
Well, in one scenario, they challenged AWM with navigating a complex web interface to book a flight, something most of us have probably struggled with at some point. The catch was the website kept changing things up, new layouts, different options popping up, you name it.
Ooh, sneaky. It's like the AI equivalent of those KPTCHA tests that make sure you're not a robot, except this time it is the robot.
Exactly. And here's where that online learning really shines. Even with all these curveballs thrown its way, AWM was able to adapt and complete the booking successfully, even outperforming methods that had been specifically pre-programmed with human knowledge of how those websites work.
Okay, now that's just showing off.
It's
It's like
cool.
sending someone to a foreign country where they don't speak the language and they still manage to not only order a meal, but also negotiate a discount. That's wild.
It really is remarkable. And it all comes down to that key concept we talked about earlier, cross-template generalization. AWM isn't just memorizing specific actions, it's understanding the underlying principles of a task, and then applying that knowledge flexibly to new situations, even ones it's never encountered before.
So going back to your map example, it's not just about knowing how to get from point A to point B. It's about understanding how a map works in general, the symbols, the scale, the relationship between different locations, so that you can navigate any map, even if it's for a city you've never been to before.
Precisely. And that's a level of flexible problem solving that's been incredibly difficult to achieve in AI until now, that is.
This all sounds incredibly promising, but I have to imagine there are still some limitations, right? No system is perfect after all. What are some of the challenges the researchers identified as areas for further exploration?
You're absolutely right. There's always room for improvement. One of the key challenges they highlighted is dealing with situations where the environment changes drastically and unexpectedly, even while the agent is trying to complete a task.
Okay, I need a real-world example here. Help me wrap my head around this one.
Imagine you're using an AI assistant to book that flight we were talking about. You've almost finished the process, you think you're about to hit that confirm purchase button, and suddenly the website throws a wrench in the works.
Uh-oh. System crash, price surge. Don't tell me they're trying to upsell me on travel insurance again.
Let's say they are. Suddenly you've got this whole new set of options and decisions to make, and your trusty AI assistant is left scrambling because its pre-learned workflow for booking a flight didn't account for this sudden change in the game.
So it's like the AI is playing a video game, and just when it's about to beat the final boss, the developers release a surprise update with a whole new level and a secret boss battle.
A very apt comparison. And that's the kind of challenge AWM and similar approaches will need to overcome to truly be effective in the real world where things are rarely as predictable and straightforward as we'd like them to be.
That makes a lot of sense.
Yeah.
It's one thing to teach an AI to navigate a well-defined set of rules. It's quite another to equip it with the flexibility and resilience to handle the unexpected. It's like they say the best laid plans of mice and AI agents
Right.
often go awry. But I guess that's where the real learning happens, right? When you're forced to adapt and improvise.
Absolutely. This is where the future of AWM gets really exciting. Imagine giving these AI agents the ability not only to learn from their own experiences, but also to share those learnings with each other. We could see a kind of collective AI intelligence emerging where they're constantly refining their understanding of the world and getting better at handling those curveballs.
Okay, now that's a future I can get behind.
Yeah.
It's like instead of each AI agent having to start from scratch, they're all contributing to this massive shared database of knowledge and experience, kind of like Wikipedia, but for AI workflows.
Exactly. And the potential applications of this technology go way beyond just booking flights or navigating websites. Think about healthcare, education, manufacturing, any field where AI agents could assist humans in complex, ever-changing environments.
So we're talking about AI that can not only keep up with the pace of change, but actually learn and adapt faster than we ever could.
Yeah.
It's both exciting and a little bit daunting, to be honest.
It certainly raises a lot of interesting questions, but that's what makes this research so compelling. It's not just about pushing the boundaries of what AI can do, it's about understanding how these advancements can be harnessed to solve real-world problems and create a better future.
It's like we're standing at the edge of uncharted territory, and the possibilities seem endless. But as with any new frontier, there are bound to be challenges and unexpected discoveries along the way.
Exactly. And that's the beauty of research like this. It's not about finding all the answers, but rather about asking the right questions, questions that inspire us to keep exploring, keep innovating, and keep pushing the limits of what's possible.
Well, I don't know about you, but my mind is officially blown. This deep dive into agent workflow memory has been a wild ride full of aha moments and thought-provoking insights. It's clear that we're only just beginning to scratch the surface of what AI can do, and I, for one, am incredibly excited to see where this journey takes us.
As am I. It's a fascinating time to be working in this field, and I have no doubt that the coming years will bring even more groundbreaking discoveries and advancements in the world of AI.
And on that note, we'll leave you with this final thought. If AI can learn to learn like this, adapting to new situations, and even surpassing human performance in some areas, what does that mean for the future of, well, everything? What new possibilities will emerge? What challenges will we need to address? These are the questions we'll be grappling with as we venture further into this exciting, uncharted territory of artificial intelligence. Thanks for joining us on this deep dive, and until next time, keep those minds curious.